Hello, and thank you for joining us today for this webinar series, Perspectives on Urban Flood Resilience, How Different Fields Tackle One of the World's Most Prevalent Disasters. This series has been convened by Dr. Kristin Raub, who is a postdoc at CUAHSI, among other things. This is a 6-part series, which will continue each week at this time until October 13th. This is the 4th talk in the series. If you're interested in viewing previous webinars in this series, which I recommend checking them out, they can be found on the CUAHSI YouTube channel. And I'll post a link to that playlist in just a moment if you want to go back and look at the previous 3 talks. But before we get started, I wanted to give a little bit of information about CUAHSI before passing it off to our wonderful speakers today. So my name is Julia Masterman. I'm the Education and Outreach Specialist for CUAHSI. CUAHSI is the consortium of universities for the advancement of hydrologic science, and our mission is to advance water science by strengthening interdisciplinary collaboration, providing critical infrastructure through our data services, and promoting education in water science at all levels through, in part, programs like this Cyberseminar Series. We seek to complete our mission in 2 main ways, through our community services as well as our data services. Our community services include things like grants and fellowships, workshops and trainings like our Snow Measurement Field School, which is pictured above, the National Water Center Summer Institute, wherein students, graduate students, work with the National Water Center in Tuscaloosa, Alabama to work on solving problems of national importance associated with the National Water Center and its National Water Model. We also host Cyberseminar Series, the CUAHSI Virtual University, and a hydrology guest lecture database for educators to find other educators who are willing to come into classrooms virtually to give talks on topics that might broaden an existing syllabus or curriculum. So I'd encourage you to check that out. One thing to note, training workshop proposals are now open. If there's a specialized topic or method that you'd like to share with the CUAHSI community or the water science community broadly, CUAHSI can help host a workshop. Please visit our website to learn more about this, and the deadline to submit your proposals is coming up this fall. I'd be happy to talk more about that if there are any questions later. There are also a number of deadlines coming up for our funding opportunities. We have 3 main grant opportunities, 2 of which have fall and winter deadlines. The Hydroinformatics Innovation Fellowship is open to graduate students and early career scientists to provide funding to enable scientists to create a hydroinformatics product that would be disseminated to the CUAHSI community. The deadline for that is November 19th. And the Pathfinder Graduate Student Fellowship deadline is December 24th, which provides funding for graduate students to travel to add a new site to their research. The other side of our house are our data services. CUAHSI provides tools and support to enable every aspect of the data lifecycle and hosts 2 main data repositories, HydroShare and HIS, or data.cuahsi.org. And that was a very brief introduction, so please, I'd encourage you to connect with CUAHSI further. If you are not already, follow us on Twitter, join our community Slack channel, sign up for our newsletter. I'll put links for all those things in the chat in just a moment. We have a wonderful speaker lined up for today, but before we get started, a few logistical things. This webinar is being recorded and will be posted on the CUAHSI YouTube channel later this afternoon. Secondly, we ask that you use the Q&A functionality to submit questions during the talk and after. There'll be time for a Q&A at the end. And finally, we expect that all involved with CUAHSI Cyberseminars promote and maintain a professional, considerate, respectful, and collaborative virtual environment. So thank you for being a part of that. And thank you again for joining us, and to Kristin Raub for putting together this lineup of presentations so far, and to our presenter today for joining us. Today's session is Collaborative Flood Modeling, a pathway for building trust and integrating equity into flood management. And I will pass it off to Kristin Raub to introduce our speaker.
Thank you for that introduction, Julia. So once again, thank you all for joining today. I'm very excited about our talk. As Julia mentioned, we will be monitoring the Q&A. So if you have any questions, we'll be collecting them throughout the presentation, but we'll save them all for the end. So again, use the Q&A function. And I am pleased to introduce our speaker for today, Dr. Brett Sanders, who is a professor of civil and environmental engineering and urban planning and public policy at the University of California, Irvine. So without further ado, I will turn it over to you.
Thank you, Kristin, and good day to everyone. I don't want to presume that it's morning or afternoon or evening or who knows where you might be logged in from. I'm sitting here in Southern California where it's a little after 9, and I'm really pleased to be with you today. I'm going to share my screen and we'll get right into it. Great. So collaborative flood modeling, a pathway for building trust and integrating equity into flood management. I'm going to draw for the first part of this presentation from a research paper that was published in Earth Future last year. You can see it has a similar name. In this case, collaborative modeling with fine resolution data enhances flood awareness, minimizes differences in flood perception, and produces actionable flood maps. So what we're getting, what this presentation or seminar will kind of cover here is a process of collaborative flood modeling, but also, how we do it, what we can get out of it, and why it's important. So let's start with a definition. I think collaborative flood modeling is not well defined. It can be interpreted in different ways, and I think that's okay. But I did want to be clear about where I'm coming from, because other terminology is also used in this space. The terminology like participatory flood modeling can mean the same thing. So here what I'm talking about is an iterative process of flood hazard model development and its application that's marked by kind of 2 key features. The first is an early and sustained participation by stakeholders. So we're talking about involvement at an early stage, not at a latter stage after models have been developed and sort of refined and so forth, but trying to get participation started early. Secondly, and this is, I think, maybe what distinguishes my interpretation of collaborative flood modeling from others, is the role that flood visualizations play as a focal point for dialogue and interaction. Okay, so we're talking about early and sustained participation by stakeholders, and we're talking about visualizations from fine resolution models serving as a focal point for conversations, for communication, interaction, conversation, and so on. And then some of the key dimensions or aspects of collaboration to keep in mind, we need to be thinking about. One is who's participating. So trying to sort of set forth a participation plan, who's contacted early on is one of those things that's typically done early in a process. Another aspect of it is really understanding the phenomena and important processes. And I think as researchers, we don't want to presume that we understand all the physical and social and aspects of a flooding problem in a particular community, but rather we have a lot to learn by pulling people into these conversations about flooding and hearing those perspectives and thinking about ways that those could be integrated into a simulation system. There's some practical things like identifying sources of data. And then there's the progression of the model, developing it, validating it, figuring out how you're going to assess performance, figuring out what kind of scenarios we want to be looking at to try to explore the range of sort of flood impacts that might happen and what we can do about it. And that gets us into like designing mitigation strategies and then finally trying to meet different decision support needs across a spectrum of stakeholders who are interested in the investments that are made and who they serve and how much they benefit different sectors of the community. So I want to now stop and share a little bit of context about why we're doing this. And the first thing is, especially speaking to a community of hydrologic modelers, and even those that are into the sort of professional services, consulting engineers, consulting hydrologists, we need to be aware of the power structures that exist in flood hazard modeling. Flood hazard models are typically developed by engineering consultants employed by private developers and/or government. And then you've got a client like a landowner or a city government or a developer who's typically the owner of the proposed project. So historically, when we've approached flood hazard modeling projects, what ends up happening is that those in power, those with resources, tend to control the development of the model, the scenarios that are developed, the kind of interventions that they're explored as a way to think about how to manage the problem. And that leaves a lot of other stakeholders feeling sort of left out of the process and in a really weak position to shape outcomes. Okay, so the first sort of, I think, issue to be aware of is that this idea of collaborative flood modeling is a response to try to create a more equitable environment for sort of understanding the flooding problem, understanding the potential consequences, and then trying to sort of think creatively about ways that it can be managed. So we're trying to kind of redistribute power in terms of participation and shaping directions and ideas and things like that. Also, I just made a note here that that stakeholder involvement has been a part of sort of flood hazard model development and mitigation planning for a very long time, but it's been done some places well and in many places not well. Who gets a seat at the table? When are stakeholders allowed to participate? What is the scope of input that stakeholders can provide? I think typically what ends up happening is when we marginalize a process of stakeholder involvement, leaving people in a really weak position to shape outcomes and shape scenarios, then those groups feel marginalized by the process. We often don't end up with solutions that address the most vulnerable communities with respect to flooding, and many times projects end up in litigation. So you've got someone that's been left out, an impact that's not been considered, and so then that ends up in a court of law, and invariably that means higher costs and delays, and that's not necessarily serving the community very well. Okay, so the first set of context here is the power structure. We're trying to sort of create a more equitable power structure. The second set of context here, aspect of context, is the sheer power of an intuitive visualization. So a good visualization allows just about anyone to immediately grasp the scope and potential consequences of flooding using familiar reference points such as streets, buildings, other landmarks. We've become a very map savvy society, across all sectors of communities typically have access to mobile phones, and we use mapping tools all the time to navigate from point A to point B. So we've actually have a pretty map savvy society, and stations that are integrated into that type of awareness and ability can allow a stakeholder without a technical background in hydrology or flooding to immediately grasp some of the implications that we're talking about just based on some well-designed flood hazard maps. And so what we're seeing then is that the power of fine resolution modeling and intuitive visualization is an opportunity to bring more people into conversations about flooding and productive conversations, because we're basically lowering the technical barriers that have existed to participating in a project and thinking about it. So what I'm going to do in the next 10 minutes or so is walk through some results of the FloodRise project, which was funded by the Seas Hazard Program, the National Science Foundation, where we were sort of asking, what is the value of this fine resolution data in a co-production process? And then one questions written out in the bottom of the screen here. How does the co-production of fine resolution flood hazard models impact flood risk management across major stakeholder groups, residents, natural resource managers, public works managers, and emergency responders. So this was the project that set up the Earth Future paper that I showed before. And this is a project where really my understanding of collaborative, flood modeling has kind of taken form. We carried out the flood hazard modeling in 3 different communities in Southern California. So I've got a pointer here. I hope you can see it. We have a community in Orange County called the Newport Bay or Newport Harbor community. And then down at the US-Mexico border, we have actually 2 different sites. One is this valley here called the Tijuana River Valley. And the river valley is made up of a lot of some urban areas along the sides. You've got communities in Mexico that sort of have watersheds that drain down into the valley. You've got a little bit of urban, development along the north coast of the valley, but it's largely a rural space made up of areas where there's a little bit of, rural housing, there's a little bit of agriculture, and there's quite a bit of space owned by state parks, and there's a Tijuana River National Estuarine Research Reserve in that space too. So we've got some natural resource areas, you've got some agricultural areas, you've got some rural housing in that area. Then another site in that region is Tijuana itself, and we adopted a community called Los Laureles, which is a sort of a fast-growing urban development in Tijuana that's on what's called sort of the urban fringe. It's not the urban core where everything's concrete, but it's an urban fringe where you've got like some informal housing, dirt roads on steep topography, and they face a big pluvial flooding and erosion hazard in that space. So across these 3 sites, we had a site with a coastal flood hazard, which was largely an urban space with a coastal hazard. We had kind of a rural space with a riparian flood, fluvial flood hazard, and then we have a urban space with a pluvial flood hazard. So what's kind of neat about these 3 sites is that we covered the coastal, the pluvial, and the fluvial flood hazards. And so in each of those sites, we convened a series of a sort of a collaboration plan, which involved, meeting with stakeholders, carrying out some survey work to sort of try to understand resident perspectives about flooding. We carried out some focus groups to kind of drill down into the types of maps and products that could be useful for different types of decision-making. And then we wrapped things up with a sort of outreach and training sessions where we created tools that were sort of co-developed by the community to sort of think about flooding and to try to serve different decision-making needs. So I'm going to kind of walk you through then with the next few slides, some of kind of the takeaways from this project and what we learned that would be really useful for other collaborative flood modeling projects. So the lessons learned. Okay, the first lesson I want to emphasize is one that, as someone trained as a hydrologist, I would have never known, but it's really important to work with a boundary organization to design and implement your engagement plan. So a boundary organization is an organization that works at the boundary between the research team and the community. And they're a group that's typically trusted within the community. They have a legacy in the community for providing trust for information, for being there as a excuse me one second. Okay. So they're an organization that is going to be there after you leave. Researchers, we have to be aware. We tend to kind of get involved in projects at sites, do science, get out. And a lot of times, if you're in a community, it can feel like a research team came in, did a bunch of stuff, left, and where'd they go? And what about all this interaction and sort of work that we were trying to do? So it's really important to have a boundary organization that's going to be there after you leave, and it's going to be there to help sort of continue the sort of impact of the work that you do. That group will also be really valuable for developing an iteration plan. So the key, science has shown that a key, what's really critical for making information research useful is iteration, coming back again and again and again, and that can be done with meetings and surveys and focus groups and training sessions or outreach. That was our iteration plan, but depending on where you are in your site, you might have a different type of iteration plan. But then through iteration, you're empowering your participants to shape key decisions like scenario selection, performance metrics, mitigation alternatives, and so on. Second key lesson from this work is that a fine resolution model really makes a difference. We did a survey in Newport Beach, which was the coastal urban area. We identified almost 2,500 households, which were selected based on different experience and exposure to flooding and different age groups and different renters versus homeowners. And we ended up completing over 200 surveys, sitting down and talking to people for 30 to 45 minutes. And we did some testing, some A/B testing to kind of compare, how people reacted to one type of map versus another. And the two maps we showed them one was a more detailed map like this one, which shows contours of flood depth from a 100-year event, versus a FEMA firm, which was showing areas classified as being inside of a hazard zone or not. And so there's really two key takeaways from this flood perception work. One is that the more detailed map was shown to increase flood awareness more than this sort of flood classification map. So people, with a sort of a Likert scale, if you're familiar with that, a 7-point Likert scale, just registered a much higher score, saying that they felt more aware about the hazard using the spatial distribution, this sort of detailed map versus the classification map. But I think what's even more important, for the purpose of trying to move forward and figure out how you're going to manage flooding, is that the detailed model minimized differences in the perceptions of the hazard across stakeholder groups. So what does that mean? That means that if you're coming into a community, you're going to find that people have, and you're talking about a flood hazard, you're going to find that people take on many different perceptions of what that hazard is. Does that hazard mean that my house is going to be completely underwater? I need to go climb on the roof? Does it mean that there's going to be a puddle of water out in the street and I might need to sort of put on some boots? I mean, those are two different perceptions of what that hazard is. And so what we found was that, particularly in this region, which is exposed more to kind of low-level nuisance flooding due to just the geography and the type of flooding that takes place, in those types of storm tides we have in Southern California, this community is really facing a hazard of sort of chronic low-level flooding, more like a nuisance type flooding hazard that, it's a different type of problem than a type of hazard that's going to leave, people needing to scramble to their attic. So fine resolution is really helpful for sort of bringing different stakeholder groups into more of a shared awareness of what is the problem that we're trying to tackle. Another key lesson was that it's really valuable to anchor learning in historical flood events. I'm showing a graphic on the right-hand side of a depiction of a historical flood event in a hazard viewer, which combines, some mapped information in a scale that we came up with to try to communicate flooding in a pretty simple way that'd be easy to understand. And we have some photos that kind of reconcile what the model's showing with what's happened at that time. And what this can do is sort of help a community kind of understand what they're seeing in a map with some familiar images like a photo and so on. So what this will do is it will enable you to have sort of more simplified conversations about flooding. And basically you can bypass any sort of conversations about what's the probability of this happen or what's the uncertainty of this happen. And when you oftentimes with flood hazard work, we work with probabilistic scenarios like 100-year events or 500-year events. And those are really hard to sort of, for many people to contemplate. So if the key issue is to try to help a community appreciate the possibility that flooding could happen and to contemplate what impacts might happen. Well, I've got property that could be damaged, or I can't get to work, or a place where I work is going to be underwater. That if you really want to focus the community on the consequences of flooding, what can be done to reduce those consequences, it's really helpful to completely bypass some of these probabilistic scenarios and work with some historical events. Another lesson that we took from this work was that it's really valuable in preparing maps information to use both qualitative and quantitative scales. So in the previous slide, I showed you a scale where we had over depth flooding and need to ankle flooding, that sort of thing. This is a map of flood force, which is sort of a tool that could be used for flood safety. And in this case, we have a coloring scheme where we're mapping the hazard based on, is this kind of flooding that people can stand in? Is it unsafe to stand in? Is a car likely to be displaced? Is a home likely to be damaged? Or is the flow so powerful that it could wash away a home? Okay, so this type of flood force information is you're able to translate what you're modeling into a specific outcome that's much more actionable. Another lesson we took was just the importance of working with different groups of stakeholders, trying to understand different needs and tailoring different maps for each of the different end users. The beauty of our modeling skill today is that we can create very sophisticated simulation models. And once we've built that model, we can easily make many different types of graphical outputs with different types of information. So once the model's made, it really behooves us to sort of take that information and translate it in many different ways to try to serve as many different needs as possible. So we found working with different stakeholder groups, for example, that among residents and businesses, there was really interest in safety and vulnerability reduction. Among sort of planning and policy folks, there's really a lot of information in policy enforcement. So what are the regulatory flood zones and flood stages? And that flood stage information is important for sort of setting permits of new construction, making sure that new homes are built above certain elevations. It can be valued for optimizing land cover, land uses, making sure we don't put critical infrastructure in areas that are really high hazard, and also aligning infrastructure projects for multiple benefits. So there's so many projects that are taking place in watersheds, and it's helpful for planners to try to align different projects so there's multiple benefits. And for emergency responders, clearly are interested in forecasting type tools, nowcasting type tools. That's a different animal than looking at historical events or even looking at probabilistic floods. But what we did learn was that one of the things that was really valued was information that kind of showed the spatial extent of high hazard areas. So if an emergency responder is getting into an area where they need to do a rescue or save people, trying to understand the spatial extent of that, so they're able to get around. Also impacts the transportation network is another one that comes up. So that kind of gives you a sense of some of the key takeaways from that first study. And now I wanted to transition for the rest of my talk and just give you a sense of how we're thinking about scaling up and making this type of collaborative flood modeling possible at larger scales. So this presents a number of different challenges. For one, how do we do this detailed, modeling with, grids, let's say 3-meter resolution over entire metropolitan areas? I mean, that's the computational demands become really, really high. Well, we have seen some advances along those lines, and we've published a paper called the parallel raster inundation model. And what it does is it uses a dual grid modeling technique. So you take the super fine resolution topographic data and you use that to understand flow pathways, and that ends up informing a slightly coarser resolution solution update where you're solving so in this case, we typically solve the continuity and momentum equations in the shallow water equations at say 30-meter resolution, while we're resolving topography at 3-meter resolution, and we're retaining detailed knowledge of topography in order to kind of come up with a better prediction. And with this sort of dual grid technique, which can also be thought of as like an upscaling and downscaling technique, we can run models, and we can run models that are faster than real time. This model for Southern California on a sort of high performance computing system, we can run a daily simulation in about an hour. So because of the upscaling, downscaling technique and parallel computing, we can now do fine resolution flood hazard modeling at metropolitan scales, and it does introduce massive data volumes, which is a challenge unto itself. But this technology is coming along nicely. What I'm showing here is a hazard map for the sort of 100-year flood zone for this Los Angeles, Orange County coastal plain. This is a region that's been struck with disastrous floods a couple of times over the last couple hundred years. In 1861, 62, there was a great flood across the west coast of the United States, and sometimes been called the Ark Storm. And that at that time, the river here, the Santa Ana River, was reported to move 6 miles up the coast. So you've got a coastal plain here. Historically, these rivers that came out of the mountains, the LA River, San Gabriel River, they would take different paths to the coast. Like the Santa Ana River might come down to Huntington Beach or out to Long Beach. LA River at one time emptied at Santa Monica. Okay, so these were very erosive, mobile rivers. This type of flooding has sometimes been called ultra hazardous flooding because of high velocities and high concentrations of sediment and debris. And the infrastructure of Southern California is not sized to contain an event of that size. So Southern California is a region where we're highly vulnerable to the next arc storm. Levels of awareness and preparedness are very low. So we're trying to think about how do we carry out collaborative flood modeling in Southern California in ways that improves the preparedness and the sort of safety and opportunities for to reduce vulnerability across the region. So we have the flood hazard modeling system, and we also are working with a team that's putting together a vulnerability index for the region that's at the block group level, so we can get a sense of where the areas that are most vulnerable, which is the white, and where are areas that are less vulnerable, which is the bluer and the darker colors. I want to walk you through a little bit of this work. This is a map of a composite flood hazard map. So when we get into these flood hazards, especially in coastal area, we need to think about compound flooding. So what I mean by compound flooding is the possibility of flooding from high tides or coastal storm surge, or from intense rainfall, or from stream flow out of the mountains. And so what we've done is for this model, we've looked at 3 main hazard drivers. One is precip, so a pluvial flooding scenario. One is sort of high stream flow out of the mountains, which is our fluvial scenario. And then lastly, a coastal scenario, which is in this case limited to extreme high tides. We aren't doing wave-driven flooding at this time. Okay, so this shows sort of the spatial distribution of what we call the composite flood hazard, which is the synthesis of the 3 different scenarios. This graphic here shows across the region which of the 3 hazard drivers leads to the most severe flooding in any location. So the areas labeled in green are areas where stream flow is the dominant hazard driver. Areas in red are areas where rainfall is a predominant hazard driver. And then areas in blue, like the one down here in Huntington Beach and in Sunset Beach, those areas are areas where storm tide is the predominant hazard driver. So we can think about different types of hazard drivers in the region. You can see also how that aligns with different types of FEMA flood hazard classifications for the region, which is kind of a patchwork of different types of flood hazard zones across the region. You can see sort of there is some alignment between the fluvial hazard and the base 100-year flood zone in our modeling. So it seems pretty consistent there. But in terms of the pluvial hazard, like it's been shown elsewhere, there's pluvial hazard that's not well mapped, right? And that's a real hazard that hasn't really been mapped and recognized and thought about in terms of how we're going to become more resilient. This is our vulnerability indicator, where it's actually characterized as a disadvantage index. So high disadvantage would refer to people who are highly vulnerable. And so the yellow are areas with a disadvantage index of 0.5 to 1. And then the blue colors are areas with low disadvantage, which would be your more affluent, less vulnerable communities. So we need to think about, okay, well, how do we intersect, this information of hazard and disadvantage, and think about resilience, and think about what can be do about flooding. So we are in the process. This is an ongoing process of engaging with many different groups across Southern California. We've been going through a series of focus groups, meetings with stakeholders, where we present iterations of our model, talk about the hazard, talk about the disadvantage, have some conversations with those who are working in the community, thinking about different challenges, and trying to kind of increase awareness about flooding, learn from people about whether the models reflect the kind of lived experiences that they have or awareness that they have. Seeing opportunities for multi-benefit projects where there's a need to sort of take action here, and taking action for this can align with, say, water quality or urban greening and things like that. And also sort of learning about limitations of the model, what's important in a particular region that's not captured by the model. So this is an ongoing process. We've been going through it for close to a year now with different conversations, and along the way, we continue to iterate the model, sort of thinking about how we represent hazard drivers, what kind of scenarios do we want to look at, how do we capture infrastructure, and what level of infrastructure can we capture. Right now, these models capture what I would characterize as level 1 and level 2 infrastructure, stormwater infrastructure, but not like your level 3 infrastructure. So we've got the major flood channels, we've got the secondary drainage channels and storm pipes, but we don't have individual street level storm inlets into the model at this time. So those are sort of some of the things that we can iterate on as we go through this collaborative flood modeling process. And along the way, we pull many different groups into the process of building this model, and feeling like it's a useful tool, and feeling like this is a tool that's going to help kind of move the region forward in terms of greater resilience. And so this type of participatory platform allows us to examine then, how are we going to invest in infrastructure in ways that are equitable, or allow us to work towards more just outcomes. So it brings more people into a conversation of thinking about infrastructure investment. It can also be a great tool for then aggregating information at the city level scale. And this is some results that's, again, work in progress here. But in this case, I want to draw your attention to the left-hand side here. Is we can take information from this modeling system and aggregate it at the scale of cities, and then think about how different cities are exposed. And so I've got some very conventional indicators on the X and Y axes here. On the X axis, I have property value per lot area. And on the Y axis, we have the average depth among exposed properties. So first, I'll draw your attention to this area of the plot. So this is the area where we have the highest hazard, city like Carson or Irwindale. Average depth among exposed properties is over 2 meters. So that's a really severe hazard. Also, some cities like Paramount, Long Beach, Southgate, which also have some severe hazard. Those are also properties with relatively low property value. Out on this axis, we have cities with high property value and relatively low hazard. Beverly Hills, Santa Monica, Hermosa Beach, West Hollywood. And then in the middle here, you've got a number of properties with relatively low property value and low hazard. But there's two more pieces of information here, which sort of this plot allows us to kind of contemplate. One is the size of the exposed population, which is drawn with a circle. And secondly, the disadvantage or the vulnerability of that community with this vulnerability index. So if we start looking at these so high property value properties might be something that under some performance measures might be a priority for investment. We need to kind of protect, valuable assets. Well, but those are areas with relatively low disadvantage. So these are more affluent communities. And over here, what we have are some communities with high flood hazard and also high vulnerability. So we see these pinkish colors which sort of reflect a higher level of vulnerability. And if we zoom in more over here, we can start seeing pockets of concern, like, there's a dot up here which is called Bell Gardens, which is highly vulnerable community, basically high disadvantage, relatively high exposed population, relatively high hazard, low property value. So these types of graphics can be pulled out of this, this modeling system based on aggregating information at different scales, and then can be a focal point for conversations about, what cities ought to be maybe priorities for infrastructure investments, what governments need to be thinking about taking action, what types of coordination needs to happen across different levels of government. So that's how collaborative flood modeling is sort of proceeding from the community level now to the regional level. And just to wrap things up here, the idea is to create a pathway, for a more genuine and transparent process of flood management, and working towards, more equitable process, reducing the difference in sort of power across those who can sort of shape outcomes. A few key points here. The visualizations from fine resolution models lower barriers for participation, including the ability to make meaningful contributions. So someone without a technical background can share their lived experience. They can raise a possible idea about what we can do about it, and they're able to engage more effectively with a visualization there. Now, there's also great opportunity to support and enhance activities focused on reducing the consequences of flooding. So the more fine resolution data, it's more effective at increasing awareness. And so that can be really effective at helping to stimulate, preparedness measures and vulnerability reduction measures. And we can also tailor data products for a wide range of decision support needs. What do planners need? What do emergency managers need? What do developers need? There's different needs that can be met. We found increased levels of trust and eagerness to participate among our stakeholders. So we found once we started this process that people kept coming back and they wanted to shape outcomes. They wanted to be involved to sort of see this through. And I think that's evidence of the evidence is there that we're reshaping power structures and equity by the fact that many different stakeholders have been empowered to kind of take different measures to address flooding. So on that note, I'd like to acknowledge the team of people that I've worked with in this project. We have David Brady has been doing the disadvantage index work for us. Steve Davis, Doug Houston, is Catherine Mock, Richard Matthew, Joe Schubert, and Nicola Ulibari have been key contributors to this work. And we've had a number of community partners, both at the local level down in our Flood Rise project, and now as we transition into all of Southern California, we've had some great support from SCAG. So funding has come from NSF and also from NOAA. So on that note, I think I'm going to wrap up and sort of see what kind of questions have come along here.
Thank you so much for that presentation. We do have some questions coming in, so just a reminder to everyone in the audience, please keep putting those in the Q&A function and I will start asking them. So the first question we got in is, Malibu is really confusing me on the depth versus property value scale. How is the property value so low? Does that include public property? Also, have you run this or neighborhoods or zip codes within the city of LA? There is quite a range of property values.
Great question. So yeah, so Malibu is an area that is in our modeling system is sort of not really capturing the coastal flood risk because they're exposed to really a wave-driven flooding. So one maybe caveat here is that some of these, a community like Malibu, which has a lot of resources, right along the beach, because we're looking at sort of storm tide type hazard and not a wave-driven hazard, we're not fully capturing the hazard there. Why the property value is low is a good question. I think it's because this is property value among exposed properties. My only sense is that it might be that the exposed properties are more inland along like, rural canyons and things like that. But I agree, it's kind of a peculiar one. So I'm not sure exactly, how that shows up like that. In terms of your question about Los Angeles, yeah, you're right that there are many different communities across Los Angeles, and so this big bubble could be broken down into smaller size groups, and I think that we even have like there is a finer level of characterization that I've seen, which is called a sort of community level classification as opposed to city. So I haven't done that yet, but it could be done to try to sort of break it down at a sort of different level. Or
Great. Our next question is, what factors did you look at to classify disadvantaged populations on a gradient? Do you have a data layer already established, or use census data or something else entirely?
Yeah, the disadvantage index, I'm sorry I didn't say more about that. That's coming from the American Community Survey, which is, as you know, is related to the US Census. And it's looking at many different indicators, such as, everything from median income to, property ownership to, gosh, there's so many variables in that. And I think that I should have probably had a slide here that lists some of those variables. We're working on it right up now, but there's literally dozens of different socioeconomic variables that go into that. One thing I'll say about this particular disadvantage index is not a racial, it does not consider race. So it's considering factors such as, economic resources, whether you're receiving aid, from the government, whether you have a high school education or college education, many different sort of indicators that, and this came out of my colleague David Brady at University of California, Riverside, who's a sociologist. And this is still a work in progress. And I don't have that all written up to share with you right now.
The next
question. But it does. I will say that that we've also looked at the SOVI index and the CDC's SVI index, and the whether you use our index or a different index, I don't think the message is vastly different. I think that a lot of the indices seem to sort of tell a similar story in terms of vulnerability and exposure. And they're just a nice resource to sort of start acknowledging some of these differences. And also, I want to acknowledge that clearly there's so much that can't be done just with indices. So we're not going to understand all vulnerabilities with an index, but it is a useful starting point for sort of some thoughts and awareness and acknowledgement of different socioeconomic contexts across the region.
Great. Our next question is, in terms of trust, was there a difference based on race, ethnicity, language, or any other factor? I'm sorry,
we weren't able to kind of break it down like at that level. There was a paper by led by Doug Houston that appears in Environment and Behavior. And if you were to search Houston and Sanders in the journal Environment and Behavior, that's the most descriptive results we have in terms of the way that the model shaped awareness and perceptions. And then in this Earth Future paper, I tried to pull together results from, that was in his work there was just from the Newport Beach site. So in the Earth Future paper, we pulled together results from Tijuana and River Valley and Newport and more of the outcomes of our focus groups, and tried to kind of try to tell a bigger picture about collaborative flood modeling.
All right. Our next question starts off with a compliment. Thank you for a great presentation on collaborative work with stakeholders. One of the difficult concepts for stakeholders is an understanding / interpreting uncertainty and its implications for decision-making, particularly if they don't have a background in formal modeling. Can you comment on your experience around this issue?
That's a really important concept. And I don't have a sort of a perfect solution to offer. I want to acknowledge, first of all, that uncertainty is really a tough thing to talk about. I'd like to also just emphasize that the way scientists and engineers think about uncertainty is not the way that the average person thinks about uncertainty. And so we often get into trouble by kind of walking in and thinking about confidence limits and things like that, which only seem to sort of make our conversations go further down a rabbit hole. I'll add that in the Newport Beach study, in our focus groups, we piloted contemplating a future sea level rise scenario based on I think it was like a certain date into the future, it was like 2050 or something, and a 100-year flood event in the future versus a 100-year flood event with 95% confidence. It went nowhere. I mean, it's so hard for people to get their head around what that means. So I think that what I've tried to live by now, which is advice that was, I think, shared by Jay Lund at UC Davis, which is that tell stakeholders what you know. Don't tell them what you don't know. So that's one way to think about. That's what stakeholders want to know, what you know, and so I mean, there's sophisticated ways you could go about it. So far, my experience is to try to keep it simple. This is our best guess of what we think the hazard is.
That's good advice. Another question is, do you plan to incorporate street level hazard data, which might inform evacuation prioritization? Do you foresee needing to account for cities like Houston with no zoning laws?
So I think two questions there. One is the emergency response need is a big one. And right now it's really being underserved by the absence of this type of information at street levels. So I think we should expect to see within the next decade that these types of street level inundation models are part of the sort of the atmosphere of early warning, notification, emergency management. It's going to happen. It's not happening yet. We're starting to see some coarser resolution forecasting tools come along, national water models coming along with certain level of support. We will get there. It's not there yet, but I think that we'll see that develop. The second question, could you refresh my?
Yes, let me pull it up real quick. Do you foresee needing to account for cities like Houston who have no zoning laws?
So I think every major metropolitan area should be thinking about a hazard simulation tool like this one. And it doesn't matter, what kinds of, laws that, whether you have zoning laws or don't have zoning laws, these types of tools, when they're available, allow for many different stakeholders, to sort of think about the flooding and what can be done about it. So you can shine up if you think that not having zoning laws is a big problem, and that may be something that's absolutely true. Is then overlay a flood hazard map and sort of implications for not having the zoning. It might be a tool that sort of further shows like the need for zoning, or so I guess I'm not sure exactly how to run with that question, but I would say that one time someone told me that if there's a problem, shine a light on it, and I think that you can sort of with these types of tools and collaborative processes in different metropolitan areas, we can start pulling many different stakeholders into processes to think about flooding, and then ideas like that one, that we need to have better planning, better land use. And all of a sudden you have an opportunity to kind of show why, because you could start layering this information along with, whatever planning or land use information you have now, and show that there's so much that's vulnerable and so much a need to maybe set building codes in different areas for people to build at higher elevation, or to, designate certain lands for different uses, because you can expect that they'll be flooded over and over again. And so when you pull, if you have a collaborative process that's more open and transparent, you sort of level the power structures and allow good ideas that are sometimes not able to be voiced to be aired and to be made more visible.
So I have a question. Sort of speaking to the audience today, do you have any calls to action you would like to highlight for the research, policy, or practitioner community? Or sort of in other words, do you feel that there's any sort of critical aspect of urban flood resilience that might merit more research attention? Or you wish that somebody else was researching more?
Well, if there's a call to action, I think among those that are doing the modeling, I think that especially the hydrologic community, we can be more aware of our role in this power structure. And I think awareness is a great starting point for sort of equity, recognizing the need to sort of engage those impacted by, or those who might be impacted by a flood hazard tool or a flood infrastructure investment. Get those stakeholders involved early, bring their ideas into your modeling process. So I guess that's my maybe message to the hydrologic modeling community is one is make an effort to engage early, and two is acknowledge the value of the visualization. There's not a lot published on that. But my sense is that it's something that a lot of people know and they sort of accept, but it's not something that we've done a great job as a scientific community documenting. And so I feel that these visualizations we make are important, and so it's just validates their use in collaborative flood modeling as a really valuable focal point for lowering technical barriers to participation.
Mm-hmm. We just had one comment come in. It's not exactly a question, but it says, telling stakeholders only what one knows may be problematic when things don't turn out the way that was expected / modeled due to uncertainty, which could potentially lead to a breakdown of trust in the modeling and collaboration. So they said, agreed, keeping things simple is key. And maybe there's a way that we can keep uncertainty simple but visible.
Yeah, that's a great point. I sort of 100% agree with that comment. And often it also comes down to like, in each stakeholder may have a different, capacity in terms of what they're looking to hear, what would be useful to them, and just being in conversation and being able to iterate and answer questions as best you can certainly positions you to do the best you can to try to share what you know, and to acknowledge limitations. So I completely agree. If there was, if we come forward with some better ways to sort of acknowledge limitations and uncertainties, that would be fantastic.
That's great. And just a final question as we wrap up here is, do you have any opportunities to collaborate or just other opportunities in general you'd like to share with the audience today? And then further, are you open to having people reach out to you with questions or to further connect?
Sure. Yeah. Anyway, I'm always open to sort of collaborate. I can make an announcement. I'm trying to find a graduate student that could work with myself and Catherine Mock on a new collaborative flood modeling project in South Florida. So if someone is a PhD student looking for an opportunity, please go to the University of Miami, search up Catherine Mock. We have a position posted there to do this type of work. And so certainly I'm excited to collaborate. I think we have a platform here in terms of our Prima modeling system, which is a nice tool for collaboration. And if people are looking for some guidance on how to sort of proceed in their area, I'd be happy to share my experience more as well.
Thank you so much. So those are all the questions and all the time we have for today, but thank you very, very much for this presentation. It was excellent, and best of luck in all your future research.
Thank you everyone for being here today and listening to my presentation, and look forward to hearing. If you want to write me a note and just connect with me, let me know. I'd appreciate hearing some feedback. It's kind of, as a presenter, it's a little odd to like not see people in the audience and like know who's here. I don't know who is out there.
Yes, it is.
So if you want to send a note and say, hey, Brett, it was good to hear from you, and hope to stay connected, that would be awesome.
That's great. We have a few thank yous coming in now, so I think it was well received.
Okay, great. Thank you.